Good evening, everyone. First of all, I would like to welcome you on Two Works Online International Workshop on Recent Trends in Industrial Automation, that is RTIA 2021. So today's session 2 is based on the live demonstration on good evening, everyone, pneumatics. And first of all, I would like to welcome you, Professor on Nishigandha Patel, online assistant professor, MIT Aditi University, Pune. So let me just brief about the madam's profile. So Professor Patel has completed BTech in Mechanical Engineering from Sinhagad College of Engineering, Pune. She was a topper throughout in academics. She has acquired 8th rank from Pune University among all colleges and branches in final year. She completed MTech in Cryogenics and Vacuum Technology from NIT Rourkela, Odisha. She is the MTech topper, silver medalist. She worked as a junior research fellow in IPR, Indian Institute of Plasma Research, Gandhinagar, Central Government Institute. She worked in a Force Motors also. She worked in MWH Global, California as an associate mechanical engineer in designing of gate and bulkhead. Her teaching experience spans 9 years, while industry experience is 3 years. She is currently pursuing PhD from MIT Aditi University in evaporative cooling refrigeration. She has published almost 10 papers in conferences and journals and guided several students at MTech level. She is also working as a principal investigator for 100 projects from KRIA, MIT Aditi University. I welcome you, ma'am. Over to you, ma'am.
Thank you, sir. Thank you so much. Wait a moment. I need to share my presentation. Sir, I'm not able to share the presentation.
Yes.
Screen is visible?
Yes, ma'am. Just make it full screen.
Yes. Okay, fine. Shall I start, sir?
Yes, yes, ma'am.
Thank you so much, Sir Patel, sir. Professor Dr. Patel. Hello all, good evening. Today I'm going to give you some live demonstration on the industrial hydraulic circuit diagrams, as well as I'm going to talk about some hydraulic circuits. What about hydraulic? What do you mean by hydraulics as well as pneumatics? Why do we learn these types of subjects in our curriculum? So let us just talk a bit about the basics of the hydraulics. So here, first question which comes into my mind is, what do you mean by fluid power? What is exactly this fluid power? Fluid power means we are actually pressurizing a fluid, and then we are making use of that pressurized fluid in terms of transmission of power. Now, whenever I'm saying a fluid which contains liquids as well as gases. So in perfection, if I pressurize a liquid and then I utilize the liquid energy, pressurized liquids energy, that would be called as hydraulics, which we are going to talk about in this session, as well as we are going to have some live demonstrations on the same. Now, if I am compressing some gases and then I'm utilizing the pressurized energy of those gases, in that sense, that is called as pneumatic systems, where pneumatic system is basically used for low load applications, as well as it works on less amount of pressures, as well as if I consider hydraulic system with respect to pneumatic system. For a hydraulic system, we always go for higher loads, higher forces, higher pressures which come into a picture. That's the reason we go for the pressurization of some liquids. Now, let me give you a common example of a liquid is water, as usual, as well as common example of gas is air. So let us talk about the densities of liquid and densities of gases with respect to standard fluids. So if I say density of water is 1000 kg per meter cube, whereas the density of air is 1 kg per meter cube. So if you compare the densities of both, then I can find out there is a huge difference, and which is almost 1000 times much more power would be given by a liquid, which is a gas, which is a water, right? So that's the reason we always go for higher load applications as well as higher pressure applications for a hydraulic system. So in most of the industries, everything is getting automized nowadays. What do you mean by automation? Automation means there would be less human interference, and we want everything which would be controlled with the help of some sensors, transducers, microprocessors, with the help of these technologies by using a fluid power. So let us just talk about the hydraulic systems. Nowadays, in your day-to-day life, you must have visited so many applications based on hydraulic system. Here also you can see some of the applications I have just pointed it out. Here you can see that there is a man who is applying a force of F1 on the area A1. Whereas you can see over here, a four-wheeler has been lifted up with the force, or the weight of that four-wheeler is F2, which is acting in vertically downward direction on the area A2. So this hydraulics is basically dependent upon the main basic law, which is Pascal's law. What does Pascal say? Pascal says that the pressure intensity in each and every direction on the molecule of that liquid is equal, which means if I need to just point it out the main things from the Pascal's law, I can say that pressure P1 is equal to pressure P2. So what is pressure exactly? Pressure is force upon area, right? So let us just take the ratio of F1 upon A1 has to be equal to F2 upon A2. What is the meaning of this? Or what is the interpretation of this diagram? I can interpret like this. If there is a man who is standing over there applying a very small amount of force F1, by just pressing or pulling one simple lever, the whole four-wheeler has been lifted up with a huge weight, right? So I can say that I'm using a pressurized energy of the fluid, which can be able to lift the huge amount of loads, and for which I require always a pressure which needs to be created on the same. So let me give you some more examples based on hydraulic systems. Everybody drives a four-wheeler, right? So you always come across some 2-3 words like power steering. You always come across a word power windows, right? So what are those? Those are actually systems driven by hydraulics. What is hydraulics? Which means you're which means you're pressurizing that liquid or pressurizing oil, and then you're making use of that pressurized oil in order to move your steering back to the original position. What is the meaning of power windows? You just press those windows with a very little amount of force, which would be given by your fingertip, right? But actually what you can see is that window is totally moving in downward direction. So that multiplication of force has been conducted with the help of pressurized fluid. So now I would like to show you one video which talk about what is the basic of hydraulics, from where this hydraulic systems, hydraulic machinery has been came into a picture. It is there from last 100 years or past 100 years, but how it came into a picture. So let us just see this video.
Over the brink of Niagara Falls, 1 million tons of water pour, and 212 feet below, the mighty torrent falls against the blades of huge turbines, creating horsepower to light 275 cities, towns, and villages, and run the motors of thousands of factories. This ability of liquids to transmit power comes from one important natural law. You can't push a liquid together or compress it into a smaller space than it already occupies. If you take a piece of ordinary pipe and fill it with liquid and put a plunger at both ends, any blow on one plunger sends the other plunger flying out. Liquids can't be compressed, so here's what happens inside. The power of your flow is transferred to the other plunger by hydraulic transfer of power. This is the simplest kind of hydraulic system. Bending the pipe doesn't affect this transfer of power at all. It goes around corners just the same. When one plunger is pushed down an inch, the other end comes up an inch, and the pound of pressure exerted at one end is transmitted to the other. Suppose we have 4 pistons at one end and only 1 at the other. Now, when the single piston travels 4 inches, each of the 4 at the other end travels 1 inch. A large piston of the same area behaves the same as 4 smaller pistons. Moving the small piston down 4 inches carries the large piston up only 1 inch, but with 4 times the force applied. This is the principle on which commercial and industrial hydraulic systems are based. Down in Dixie, billions of pounds of cotton are baled up every year by the power of hydraulic presses. With Uncle Sam's long-range guns, not only are power and reliability needed, but minute precision is required. Precision that aims these mammoth guns within limits of 1/1000th of an inch hydraulically. The hydraulic stage works by the same method and times its cue right on the nose with the reliability of an old-time actor. This model is a hydraulic system which shows how the hydraulic press multiplies power. This is the pump. This tube holds the liquid through which the power is transmitted, and these 4 cylinders at the other end receive the power. The movement of the large piston compresses or crushes anything put in the press. The hydraulic stage operates with the same reliable element. The accurate hydraulic transmission screw in the coast defense gun is more complicated, but in principle, it is the same as the lift and the press. In any hydraulic system, regardless of how many cylinders are attached to a master cylinder, each of the small cylinders receives the same amount of pressure.
Okay, so we will move ahead. As you all must have got an idea about the previous or the history about the hydraulic system. So let us quickly just revise the components which are required for building up the hydraulic system. First of all, there is a tank. After that tank, in that tank, there is an oil which is equal to an atmospheric pressure. If the tank is open tank, it would be equal to atmospheric pressure. If the type of the tank is closed one, it would be somewhat higher than the atmospheric pressure. Then there would be a placement of a filter which would filters the whole fluid and send towards your hydraulic pump. What does a pump do? Pump will increase the pressure on the fluid which has been taken in from the tank, and the required appropriate amount of pressure to the system would be sent through the pressure regulator, which will always regulate the amount of pressure required for the whole hydraulic system. Then it goes towards a control valve. There are different types of control valves. Basically, direction control valves will give always the direction where fluid has to flow. Flow control valves will always control the amount of discharge. How much amount of discharge should be sent? Because flow rate, Q, is nothing but velocity. What it is? Velocity upon, yes, anybody? Unit of flow rate is meter cube per second. So it is either area into velocity, or it is that much amount of volume per unit time, right? So what we are doing in flow control valve, we are actually controlling the amount of flow rate with the help of some FCVs, flow control valves. Then it goes towards the cylinders. there are different types of actuators. So one of the type of actuator is called as cylinder. So there are two basically types of actuator. One is called as linear actuator. So in linear actuator, which gives you a linear motion, that we call it as cylinders. And there are several types of cylinders like single acting cylinders, double acting cylinders, telescopic cylinders, tandem cylinders, and so on. And if we talk about the angular actuators, those are nothing but the hydraulic motors, right? So basically, actuators is that part which is connected to lift anything up or to provide that force to our application. So quickly, let us just see some of the circuit diagrams. Then I will show the demonstration of these circuit diagrams on our hydraulic systems or hydraulic units. So quickly, I just would like to tell you about, this is the symbol for a tank. So these are some circuit diagrams with some specific symbols which has been used for the hydraulic system. This is a symbol for an hydraulic pump. So what is the meaning of this? There is an electric motor which drives this hydraulic pump, which will pump the oil from the reservoir, and it would be sent towards the DCV. So this is called as DCV, direction control unit, which will give the direction to your cylinder. Now, the type of this DCV is 4x3. Here I can say that this is compartment number 1, square box 1, square box 2, and 3. So there are total 3 compartments, and in each compartment, there are totally 4 walls. So wall number 1, P, A, B, and T. So in each compartment, there are 4 walls. So the name of the DCV is 4x3 DCV. Whereas here you can see that the name of the DCV is 4x2 DCV, which has been used. Now, the mode of actuation means how we drive that DCV. So here they have shown a lever. So I can say that the mode of the DCV is lever operated 4x3 DCV, which means I need to operate this cylinder, or this part is called as an actuator. Actuator is nothing but going to apply some force on your application and going to move that application either to the left or to the right, which means it is going to give you a linear motion. That's why here I'm going to show you the linear actuator as a double acting cylinder. So let us just quickly say how this cylinder is going to move, or how this cylinder is going to operate. Similarly, in the same circuit, I'm replacing this linear actuator with the help of rotary actuators. So instead of this double acting cylinder, I've replaced it with an hydraulic motor. So we need to see how this hydraulic motor is going to operate. It is either going to rotate in clockwise or anti-clockwise direction, giving you some torque with some angular velocities, right? Now, what is the main use of this linear motion of the cylinder? Let us consider there is a huge load of, let us say, 500 kgs, which has been placed in one place and which needs to be moved from one place to another place. So for a human being, if we need to push this load of 500 kgs from one to another place, a huge amount of force is required. But with the help of hydraulic systems, it would be moved within a fraction of seconds, right? So for these main purposes, we are using these hydraulic circuits. So these are very simple hydraulic circuits. So let us just quickly see how we are going to demonstrate the same circuits and how they are going to operate. Now, in this third circuit diagram, I have shown there is in between the addition of FCV, flow control valve, which is going to control the amount of flow rate which is going towards your cylinder, as well as in parallel combination, there is a check valve which has been attached over here. So let us quickly understand the same circuits on our demonstration. Okay, I'm just pausing it, stopping it over here. We'll move on towards our demonstration, guys.
हेलो हेलो ठीक है
Yes, you're audible.
लाउडली बोलो हेलो हेलो हेलो
Yes. Yes, you're audible, ma'am.
ठीक हेलो हेलो हेलो
Yes, you're audible.
ठीक सर फक्त थम्स अप करा झालं लाईव्ह करायच्या आधी थम्स अप करा okay thank you so guys let us just see this is our whole hydraulic kit I will just introduce all different components on this hydraulic kit here you can see that there is a component which contains the whole oil reservoir as well as there is a hydraulic pump inside it the type of pump which we are using is a vane type of pump here you can see that there is an electric motor which is actually driving an hydraulic pump here you can see that there is an pump distributor which means whatever oil which is coming up pressurized oil that would be distributed to your whole circuitry from this distribution channel. Here you can see the actual pressure which would be generated with the help of your pump. Then there you can see that this is an tank distributor where all the fluid would be sent towards back to the tank from the whole hydraulic systems. Here I can show you this is an 4x3 lever operated DCV. This is operated with the help of lever, so it is called as manual mode of actuation. So we can operate the same 4x3 DCV with the help of these levers. Here you can see that there is a double acting cylinder. Two ports are there, port number 1 and 2, so A and B. So that's the reason we are calling it as double acting cylinder. Here in this experiment we are going to see how the cylinder is going to extend or it is going to retract. What is the meaning of retraction? When if this is a rod end, if it is going to come out, it is called as retraction stroke of the cylinder. If this rod end is going to go in, it is called as extension stroke. It is called as retraction stroke, and when it is coming out, it is called as extension stroke of the cylinder. Here you can see that these are some roller switches. So these are switches which has been provided in order to give the stroke length to this double acting hydraulic cylinder. So how much is the stroke length, that would be calculated and that would be shown over here. Then here you can see that there is an FCV, flow control valve, which has been added up into the system in order to monitor the amount of flow rate which is going towards our hydraulic cylinder. Now let us quickly start our demonstration with the help of manual mode of actuation. So what I am doing right now, I am going to just explain all the connections which has been made in this circuitry. First of all the connections which are coming up from a pump. So there is a pressure line distributor. So this is the line which carries a pressurized fluid towards an DCV. Here you can see the 4x3 lever operated DCV. So pressurized fluid has been connected over here. Here also you can see that there is a port piece written down over here. So pressurized fluid of the DCV has to enter into this port of this DCV. Then the fluid which is coming out from the whole circuitry should go towards tank. So here you can see that there is the letter T has been placed over here. So I have connected one hose pipeline connection from this T port towards the tank distributed channel, which is again going back towards a tank. Again its pressure would be increased and the same pressurized fluid is again coming back towards your DCV from port P. Now, let us quickly talk about these two ports. So, these two ports are nothing but going towards your cylinder, but in between we have placed an FCV. So, how the flow is going to took place? So, pressurized fluid is going to come from here and then it is going to go through an flow control valve. Here we can monitor this flow rate of this pressurized fluid with the help of this knob. So, ultimately that is going to monitor the speed of your double acting cylinder when it is either going to extend or it is going to retract. Okay. Then the fluid which is coming out of this FCV, this pipeline connection is given to one of the port of your double acting cylinder, which means in between DCV and cylinder we have placed one flow control valve. Then, so pressurized fluid will enter from this port as well as when it is going to extend, at that time fluid is going to come out from this port of the cylinder and then it is going to go back towards the DCV and from DCV it is going to go towards the tank port and then the circuit is going to be finished. Again it is ready for the new set of readings, right. So, this is how we call hydraulic circuit as a closed loop circuit. So, let me just quickly start the whole setup and we will see the performance of motion of double acting cylinder, whether it is extending or whether it is retracting, depending upon how I am pressing a lever, and then we can also monitor the amount of flow rate with the help of FCV and we can again see towards the motion of the rod end of our cylinder. So, here I can see that this pressure line is active. So, this is a DCV. So, I am pressing this knob or lever of this DCV in vertically downward position. So, what you can see over here is the rod end part of your double acting cylinder is getting extended. So, pressurized fluid is going to enter into this side of the port. So, there is a piston inside a cylinder which would be moved in outside direction. So, again when I am releasing this lever, it is coming back towards its middle position, is called as an hold position. So, whatever position has been acquired by this double acting cylinder has been kept on a hold for that much particular period of time. If I am pulling this lever in upward direction, then there would be an retraction stroke of your double acting cylinder which is taking place, as the opening of flow control valve is very less amount, hardly 10% opening has been given. So, that is the reason you can observe over here speed of my cylinder is very slow. So, the piston coming out or moving in is at very less amount of speed and this is how I can manually operate this DCV with the help of hydraulic system. What I am going to do now, there are these roller switches are going to actually sense the movement of this cylinder rod end. So, once this rod end would be reached towards that end, these roller switches are going to sense the motion that the end stroke has been happened and now it is ready to switch its position, switch the position of the DCV, which means retraction has been completed and now we are ready to go for extension. So, let us quickly just one more time see the extension stroke, but with the help of opening of our FCV. Here you can see that as I have opened this my FCV with almost 60% opening, so speed has been increased as compared to earlier. Now, this was all about the manual control of the DCV. Let us just quickly switch the DCV to our electronic mode. Nowadays, this manual control is going to get something absolute. So, everyone is going towards automation, everybody is going to make everything something automatic. So, let us move towards electro-hydraulics. So, this circuit which I have told you was telling you about the basic hydraulic system which has been driven or run with the help of some manual control. And now, let us just switch the DCV from this 4x3 lever operated spring loaded DCV towards both sides solenoid operated 4x3 DCV. So, what I am doing? I am just exchanging all those 4 connections and putting all those 4 connections over here to this solenoid operated DCV. So, just give me a second. This is a tank port. So, I am connecting this tank port towards the tank port of this DCV. It is a press fit connection, as this press fit connection will ensure that the leakage of your hydraulic system would be very less. Here there is a pressurized port. So, I am removing connection from here and pressing it over here. If you wanted to see, you can see over here I am pressing it. So, here you can see that there are some ball bearings. So, with the help of these ball bearings, the leakage would be minimum. Okay. So, I am just pressing it towards our port P. I am removing A side connection of my DCV and placing it over here. Now, let us quickly just see how the circuit is going to operate. Now, what do you mean by solenoid? Solenoid means we are going to give some electronic signal to move this position of 4x3 DCV. Here you can see that there are 2 wires which are coming out from this side DCV as well as 2 wires which are coming out from this side DCV. So, inside in between this there is a magnetization which is happening and which is going to give a signal to them. This red color wire I can give a 24 volt supply, and with the help of this black color wire I am going to ground it all. So, here you can see that there is a panel which gives you some electronic signals. This is a plain signal panel where all red color says that I am giving 24 volt supply, black color says that I am grounding all the connections. Here you can see that these 2 are same panels which are changeover relay panels. So, I am making use of the relays in order to switch different positions of or different positions of the DCV with the help of solenoid. So, I just use normally closed as well as normally open contacts of the DCVs with the help of solenoids, and then I operate the extension stroke as well as retraction stroke of my cylinder. Similarly, here on the last panel you can see that there are some buttons. These red color buttons are non-latchable push buttons, which means if I press them, if I just release them, they will come back to their original position. If you see this green color button, if I press it, it will just be there at its position unless and until I just press it once again. So, I am pressing it once again, it will come back to original position till that time it will remain to the same position. Now, this is all about the electronic connections which we have. Let us now just see how we can give a signal to this solenoid in order to operate this double acting cylinder for its extension as well as retraction stroke. What I am doing is, I am taking this black color wire of this side solenoid, giving it a ground and giving it a 24 volt supply. Right now, I am just giving a supply to only one side solenoid so that we can see how its operation is going ahead. As my whole setup is in a working condition, here you can see that I have given electrical supply to this solenoid. So, there is inside red color LED which has been glowed up. So, this says that this solenoid is energized and it is right now operating into extension stroke of my cylinder, but here you can see that the cylinder is already in a extended mode. So, this solenoid has finished its operation. I am just removing these wires and connections, and now I am giving 24 volt supply and ground supply to this side of the solenoid. So, I am just placing this red wire into 24 volt and I am giving black color wire into the ground. So, here you can see that our cylinder has been already retracted because this solenoid has been energized. So, this is how we go towards one step higher to the manual hydraulics, which is called as electro hydraulics. Now, let us just go one more towards this electronics with the help of use of some change over relays. So, I am just removing these two connections. I require some more patch cords for the connections. So, I am taking some patch cords with the red color as well as black color. How I am going to do the connections? First of all, the red color connection of this side solenoid, I am just giving it normally closed supply. Again, from this side solenoid, I am taking red color wire and giving it normally open supply. So, this yellow color switches shows it is a normally open and green color shows it is a normally closed. Blue color shows it is a common which is given to this normally closed and normally open. This black color shows it is a ground supply, red color shows it is a 24 volt supply. So, just now I have just put the red color switches of both solenoids into open, normally open and normally closed. What I am doing is, I am giving 24 volt supply to this relay channel from this side. So, I am pressing or I am just putting red color wire into 24 volt. I am taking a 24 volt supply from this normal channel. I am giving it to this red color which is going to give you the supply. I can give it over here or I can give it to the common which is in connection with this NO and NC. So, I am just putting it over here. Now, the circuit is not yet completed because all the black color wires of both the solenoids are not yet connected. So, I am clubbing all these two black color wires into one wire. So, I am clubbing both black into one. Then, I need to give a ground supply from here towards this changeover relay, right. So, I am pressing or I am putting this wire into black color. Then, I am again clubbing all these wires into one wire, and then I am putting all black color wire into one wire or one loop which is given for a ground here at the bottom. So, here you can see that now this solenoid has been energized. This solenoid is for the retraction stroke of the cylinder, as your cylinder has been already retracted. So, it is not showing you any position. What I am doing is, I am just switching NOs and NCs. Then, I am just flipping this NC into NO and NO into NC. Then you can see that this solenoid would be energized, and at the same time just give it a look towards the motion of the cylinder. So, here you can see that the cylinder has been retracted due to just flap over the NOs and NCs, because I have given supply to this common I've grounded everything. I'm taking all the time supply from this and grounding it. So this is how our changeover relay works. Now let us just quickly see how the whole circuit would be run with the help of latchable and non-latchable push buttons. So red color ones are non-latchable push buttons, whereas green color one is latchable push button. So I am just removing all the connections from here. Okay. Once again I am going to tell you how I did the connections. I have red and black from this solenoid, I have red and black from this solenoid. What I am doing is, I just wanted to use this red color non-latchable push button. So I am putting both the red colors into NO and NC. So NC is green color, so I am pressing it over here. This is NO, so I am putting it over here. Okay. Then both black wires would be grounded with the help of this black color wire. So I am grounding all black wires into one, and all wires would be grounded back over here. Still the circuit is not yet completed. Why? Because 24 volt supply is not given to a common. Common is shown with a blue color. Now you have made all the connections for this non-latchable push button, which is shown over here with a red color. So I am taking a 24 volt supply, I am giving it to this common. So here you can see that the retraction motion of your double acting cylinder has been taken place due to this solenoid which has been energized. So let us quickly just press this latchable push button. So what has happened? Because of this non-latchable push button, I can continuously switch over both the solenoids. So here I can get a better control. So here you have seen how we have moved from lever operated DCV towards both side solenoid DCV. From both side solenoid DCV I have given normal 24 volt supply and ground. Then I have moved on towards relay, and now I am using this button, which is non-latchable push button. Now if I am just pressing it, I am keeping it a hold on this button, so it will continue the motion. If I am leaving it, it will move back towards original position. I am pressing it, it is coming up, again I am leaving it, it is going back. So this is how this non-latchable push button works. There is a continuous switching of both solenoids. So let us quickly see how latchable push buttons will work. Now I am not going to move all these grounds. I need to put each and every connection below this green color button. So I am just removing both red color wires of both the solenoids. I am just putting both red color wires of the solenoids into, I will show it again, both red color wires of both the solenoids will go into NO and NC. All black color wires of both solenoids, as well as I am taking a ground supply from here, everything will go towards a ground. So everything would be grounded up. Then I am taking a 24 volt supply, and I am giving that same 24 volt supply to this common. So here you can see that this solenoid was energized and it has performed its extension stroke. I am just pressing it, it is pressed, I have left my hand. So it has again completed its stroke. Unless and until I am pressing it one more time, it is going to not come back towards original position. So this is how, with the help of electro-hydraulics, this whole linear actuator is going to work. So I am just closing this circuit, and what we are going to do is, we are going to see the operation of, here we are going to just see the operation of this both side solenoid operated 4x3 DCV with the help of angular actuator. So, this double acting cylinder was an linear actuator which was giving you a linear motion in the form of extension stroke and retraction stroke. So, let us just remove these inlet connections of this cylinder and replace those two connections with the two connections which are given towards your hydraulic motor. So, this is connection A and this is connection B, and how we are going to see the motion of the hydraulic motor. So, I have moved it. नाही अजून हेच आहे, दिसत नाही, ठीक आहे. Fine. Okay. So, I moved one of the connection of our double acting cylinder and I am just pressing it over here towards our hydraulic motor. Okay. I am removing this connection also. I will press it, fit it over here. I am just replacing two ends of the cylinders with the two ends of the motor. Fine. So, both the connections has been made. So, now let us see how I can operate this hydraulic motor. Hydraulic motor would be given supply either to this A and or to this B. So, as we have seen for the cylinder, cylinder was either extending or it was retracting. So, it was pushing a load from one place to another place. Here you can expect the rotary motion of the shaft. So, I can say that in case of hydraulic drilling machine, we are placing a drill bit into a spindle and that spindle would be rotated in either clockwise or anti-clockwise direction with the help of hydraulic motors. So, whenever we need an angular motion from the actuators, we are making use of the hydraulic motors, and whenever need a linear motion, we are making use of linear actuators. So, quickly just see how the shaft is going to rotate, whether it is going to rotate clockwise or it is going to rotate anti-clockwise depending upon both side operated solenoid valve with the help of some electro-hydraulic system. So, same connections I am going to place for push buttons. So, just give me a second. All red color wires into NO and NC. All black color wires needs to be grounded up with the ground signal taken from here. So, I am putting it over here into black color wires. I am giving 24 volt supply and giving it towards the common. Okay. Now, let me quickly just start the whole setup, and here you can see that this motor has been started rotating in clockwise direction, right. Here you can see that I have marked it with a pink color. So, pink color is rotating in clockwise direction. Now, if I will press the green color latchable press button, then the solenoid signal would be switched. As solenoid signal would be switched, then this motor is going to rotate in anti-clockwise direction. So, here you can just give it a look. I am pressing it, it has reversed its position. I am pressing it one more time, it has reversed it. I am pressing it, it has reversed it. Okay. So, this is how this hydraulic motor or an angular actuator is going to show its performance with the help of electro-hydraulic system. It is majorly used in case of the hydraulic drilling machines or wherever we require a rotary motion. Now, quickly let us see one more hydraulic circuit which is nothing but based on lowering a very heavy load in vertically downward direction. So, I need to just wait for a moment. Okay. Welcome back. We are moving towards the lowering very heavy loads in vertically downward direction. Actually, what happens into industry, you can just focus it over here. Here you can see that red color dead weight is shown, which is equal to a weight of 10 kgs. And when we require to move it in vertically downward direction, weight of that 10 kgs is moving in downward direction with the gravitational force. So, the amount of force required for that pressurized fluid in order to hold that 10 kgs weight as well as in opposite direction to gravitational force it has to act. So, while moving heavy weight in vertically downward direction, there are some accidents which may happen into industry. For that particular reason, we need to provide a very slow control or very controlled motion of that heavy load in vertically downward direction. Now, let us quickly just see the hydraulic circuit diagram for moving it down. For moving it down, for vertical cylinders, we always use a counterbalance valve, or option to that counterbalance valve is we can use pilot operated check valve also. So, quickly just see over here, or else in order to slow down the speed, we can use FCVs also. Okay. So, here you can see that this is a pressure, this is pressure distributor where the pressure gauge has been attached. So, pressurized fluid from this tank is coming on this distributor line. I have made this connections to both side operated solenoid DCV. Here you can see that there are total 4 ports for 4/3 DCV. One port is P, where I have connected this pressurized line. Here you can see that there is a tank port where I have connected this tank port into tank distribution line where it is going back towards tank. The two ports of the DCBs are left, and those two ports of the DCBs would be connected towards the two ports of the cylinder, as well as I have placed in between and flow control wall. I can replace this wall with the help of check wall, as well as in parallel combination with check wall I can replace it with the help of counterbalance wall. Okay. So, what this flow control wall is going to do? It is going to reduce the amount of flow rate which is going into the cylinder, its upper side, so that when less amount of flow rate is going to go into upper side of the cylinder, this piston is going to move very slowly in vertically downward direction. But the dead weight of 10 kgs which has been attached over there, so the fluid which is present on downward side of the piston would be capable of holding the weight of 10 kgs as well as creating a back pressures on the piston, so that we can see there would be very slow motion of that 10 kg dead weight in vertically downward direction. Whereas, we can control that motion with the help of this knob which is there on FCV, right. So, I am just quickly starting the whole circuit. Okay. One more thing I would like to explain over here, both sides solenoid operated 4/3 DCB is there. So, I have done all the connections for latchable push button. So, here you can see that the same connections I am using it again and again in order to just switch over both side solenoids, and I need to switch quickly over the extension and retraction stroke of the cylinder. So, I am starting the whole circuit. As I have started a circuit, you can see that the solenoid has been energized. As the solenoid is energized, which means this dead weight of 10 kgs is in the retracted position. When it has to move in vertically downward direction, at that time you just focus over the speed of dead weight. So, what I am doing is I am just pressing a push button. So, here, so please zoom it over here, you can see how slowly this dead weight is moving in downward direction. What is the meaning of this? This pressurized fluid is that much capable of holding a weight of 10 kgs and moving it with a very less amount of speed in downward direction. So, this is how we can see how the hydraulic control is so much precise and it is taking so much amount of pressure with the heavy loads. Just look at the speed of this dead weight with what it is moving down, and then you can see the speed. I am just reversing all the connections with the help of push button. So, you can see now speed of the dead weight when it has came up. So, again notice the speed of both. Whenever it is moving in down, there has to, or this type of circuit in industry is called as fail and safe circuit, or it comes under one of the safety circuits, like you always have an emergency control to your treadmill, right. So, there is a red color button on a treadmill, you just press it whenever you want to stop emergency, right, immediately. At that time you are just pressing it off. Similarly, whenever there is a huge amount of weight attached to the cylinder and it is moving in downward direction, we need to take care of the speed. I am just changing it so you can observe the speed. So, this is how we can see the same hydraulic industrial circuit for counterbalance valve, and counterbalance valve is always used for the vertical cylinders. Okay. So, wait for a moment. Okay, time up. Okay, fine. Thank you so much. Guys, anybody is having any doubts?
Yes, dear participant, if you have any doubt.
Hello, ma'am.
Yes, sir.
Am
Yes.
I audible? What is the cost of this hydraulic kit?
The cost of the kit is approximately 4 to 5 lakh for per workstation. So it's a double-sided workstation. We can operate, both persons can operate on this side as well as both can operate on that side. It's a industrial or it's a institutional or academic version where we can pick up some of the components from the component list which is shown over here. So students can come up, they can choose the components which are required for their hydraulic circuits. Here you can see that this is single side 4 by 2 DCV. How to identify? Here you can see 4 ports are there. Only one solenoid is there, so single solenoid DCV is there. This is an check valve. This is a pressure relief valve. So these are some of the components which has been listed up over here. Yes, any other questions?
What are the specifications? If we want to know the specifications
of the whole
this hydraulic kit, what are the operating ranges?
pressure ratings you want?
Yeah, the operating ranges for pressures, then for the movement of the piston, then we can say the velocity of the piston with which it is moving. So what are the ranges specified for this particular hydraulic kit?
Okay, fine. This is a customized one. So the pressure rating for this kit is approximately 60. We can reach up to 60 bar. Okay, and velocity we can control with the help of FCV, and we can monitor that velocity, and we can achieve a velocity of 3 meters per second, 5 meters per second, which we have already achieved it. And we have used a vane pump, balanced vane pump inside the whole kit. Anything else?
Okay, thank you.
Yes, thank you.
Okay, thank you. Thank you very much.
Thank you.
Yes, dear participant, if you have any question, feel free to ask.
Any other questions?
Yes, the feedback link is already shared in a chat box. So all participants, please go through that feedback link and give your valuable input. Yes, any question from participant side? So I think, ma'am, all are satisfied with this in-depth demonstration.
Thank
So,
you. Thank you.
So thank you very much, Nishigandha Patel, ma'am, for delivering such a wonderful session on hydraulic circuit. The session was itself very informative, and you have explained it very well with live demonstration. So thank you so much for delivering such a wonderful lecture on hydraulic circuits. Now, I would like to thank all the participants for their support and for listening patiently. Thank you all. Thank you so much. So just I declare here the session is end.
Okay.
So Ashish sir. Ashish sir. Yeah. So recording, can you stop it? Yes, yes.